Welcome to lecture number 22. So today we are going to verify the Heisenberg's uncertainty principle for quantum mechanical harmonic oscillator. At the beginning I have written the two wave functions for n is equal to 0 and n is equal to 1. Okay. So you can easily derive them from the formulas that I have already shared with you, and it is available in your textbook. So sigma x square is defined as the average value of x square minus the average of the square of the average x. All right, and similarly sigma px square is defined as px square average minus square of the average of px values. So in order to find out sigma x and sigma px, we need to figure it out all these four quantities. So let's start with average of x. Okay, so the average of x, we can actually find it out from the following formula: minus infinity to plus infinity, and then we arbitrarily we take any psi n. So x cap psi n x dx. Okay, so that's what we have deduced earlier, the average expression, and here this operator actually works in a multiplicative manner, so we can easily write the same thing something like this. All right, now let's take a look at that. So this part is an even function for any value of n, either n is even or n is odd, and this x is an odd function that we have already known, and so together this gives us an odd function. So by definition, from minus infinity to plus infinity, the odd function, integration of odd function over dx is equal to 0. So for any value of, for any n is equal to even or odd, the average of x is 0. All right, and similarly what we can see is the average of px is minus infinity to plus infinity, and then we have minus ih cross, we have psi nx, and then ddx of psi nx dx. All right, so that we need to figure it out. Now before we proceed further, we must appreciate the fact that ddx of any odd function, okay, is equal to an even function, and vice versa. So ddx of any even function is equal to odd function. All right, so what happens here? So for any value of n could be either odd or even. If n is odd, then the first derivative of this one is become even, so even multiplied by odd is odd function, and if n is even, similarly we can prove that this entire value of this integral becomes an odd function. So similarly, minus infinity to plus infinity, integration of odd function dx is equal to 0. So from these two we get that for any n, okay, so we can write it here, for any n means for any quantum vibrational quantum number, the average position is equal to the average momentum is equal to 0, and this result is expected or reasonable, right? Why? Because as we have already seen, from a particle confined in a one-dimensional box, the average value of position is the mid position. So here we can think about that, here we can write x is equal to 0, and this side it is negative and this side it is positive, so the average position is always at the mid position, x is equal to 0, that means the equilibrium bond distance. And similarly the momentum, all right, that we can expect that this is average momentum is 0, because the probability of momentum having a value negative is equal to the same magnitude with the opposite sign. Okay, so as a result we expect that the average momentum is 0. Remember, this is not the actual position or actual momentum, these are average. Okay, so that means this already considering the statistical implications. Okay, so we have already deduced the value of this 0 and this is equal to 0. So sigma x square is equal to, therefore, the average of x square, and sigma px square is basically the average of px square. Fine. So now we are going to find out what is average of x square and average of px square. So I'm going to clean up the board and I will freshly start over. All right. So now we are going to find out average of x square here. So average of x square gives rise to this expression. Here we can see that x square is an even function and this part is even. So totally this is an even function. So we cannot easily by a formula predict the outcome. Okay, so we have to do the integration. So here what we can do is, first let's try to derive it for n is equal to odd, and then another thing for n is equal to even, and then let's try to find out whether we can produce a trend. Okay, so for this, first let's take n is equal to 0. Okay, so whenever we take n is equal to 0, we have to deal with this function psi 0x. So therefore the same thing becomes is equal to minus infinity to plus infinity x square, and then if I take this function and square it up, so we have alpha divided by pi whole to the power whole to the power of half e to the power minus alpha x square dx. All right, so this would become the integration. So the question is, what is the value of this? So to solve this, we need to take the help of some standard integral. So if we take the help of standard integral and solve it, it can be shown that this is equal to 1 by 2 multiplied by 1 by alpha. All right, so now the question is how this value can be derived from this integration. Okay, so I think it is reasonable that if we try to get the answer by following the standard integral. Okay, so let's write the expression of the standard integral and then let's find out or verify that in fact this integral is equal to half 1 over alpha. Okay, so let's try that out. Okay, so I have written the expression of standard integral here. Okay, so this integral in the form of 0 to infinity x to the power 2n multiplied by e to the power minus ax square dx is equal to this expression. Now I have found this standard integral in the first page of your textbook. Okay, so there are certain expressions for standard integrals are given and you are supposed to follow that. So how we can relate this integration with the standard formula? So let's make it simplified here. So this value is equal to, we can write alpha divided by pi to the power half. So minus infinity to plus infinity, this integral, this is actually an even function. So for an even function, we can write that twice of 0 to infinity x square e to the power minus alpha x square dx. Okay, so that we can easily write, and then we are going to now incorporate or apply the standard form to this integration. So let's look at that. So here x to the power 2n, so here x square, so here means here n is equal to 1. All right, so the numerator goes 1 multiplied 3 multiplied 5 up to 2n minus 1. So here since n is equal to 1 means 2 minus 1 means 1, so the numerator would be 1 divided by n is equal to 1 means 2 square. Okay, and here n is equal to 1 means here a is alpha. Okay, so we can directly write alpha and multiply by pi by alpha to the power of half. All right, so we can take this value here and we can write alpha divided by pi to the power half multiplied by 2 multiplied by 1 by 2 square alpha pi by alpha to the power of half. So now we can see these alpha alpha cancel out, pi cancel out, and what is left is equal to 1 over 2 multiplied by 1 over alpha. All right, so this is our value of average x square for n is equal to 0. All right, so that's how we have calculated. So now we are going to find out the average of x square for n is equal to 1. All right, so let's clean the board and let's work it out. Okay, so now let's do it for x square average n is equal to 1. So this would become is equal to it would come to this expression. Okay, so here x1x, all right, x1x is actually given by this expression, so this is a relatively bigger expression, so then we have to basically square it up. So while we square it up, we take the constant values out of the integration. So let's try to write it. So we have alpha divided by 4 pi to the power 1 over 4. So alpha divided by 4 pi to the power 1 by 2, because we are just squaring it up, and then 2 comes out as 4 and alpha to the power half comes out as alpha. All right, so this is our constant part, and then minus infinity to plus infinity. Now we have x square, and this x has to be the square, so x to the power 4 together e to the power minus alpha x square dx. All right, so this is our whole integral. So now we can further write it as alpha divided by 4 pi to the power half 4 alpha multiplied by 2 0 to infinity x to the power 4 e to the power minus alpha x square dx. All right, so now this part is actually comes from our standard integral, so we have to follow the exact same standard integral that we have just worked out a while ago. So you have to apply the expression from the standard integral, and don't worry, in the test or in somewhere else you will be given the value of the standard integral, so you don't have to remember. So this is equal to, if we apply the standard integral and do all these calculations, it can be shown that this comes to 3 by 2 1 over alpha. All right, so it's your job to verify whether this equals to 3 by 2 1 over alpha. So this is the value for x square average for n is equal to 1. So here we are getting this value, and let's remember that x square average for n is equal to 0 was 1 by 2 1 over alpha. So for here, by testing two consecutive n is equal to 0 or n is equal to 1, that means for testing two consecutive or an even number, you see we get a trend in the expression of x square average. So what is the x square average? So we can write from here that x square average for n is equal to any, we can write that is 1 over alpha multiplied by n plus half, where n is equal to 0 1 2 3 etc. up to infinity. Okay, so for n is equal to 0, this becomes 1 over alpha multiplied by half. For n is equal to 1, it becomes 3 by 2 1 by alpha, and similarly so on for any value of n is equal to 2 3 4 5 6 etc. Someone can verify that this is the expression. So finally we have been able to solve our sigma x square, which is for any n, for n is equal to any, it becomes this value minus 0. So because x average of x square is 0, so together we can write this as 1 over alpha n plus half. All right, so we have solved the sigma x square value for n is equal to any. Okay, so now we have to do the same exercise for sigma px. Okay, so let's work it out once again. Okay, so now we are going to find out average of px square with n is equal to, at n is equal to 0. So now you see this is the expression for psi 0x. So psi 0x and then multiplied by the operator for p square x, and then again it's operating on psi 0x dx. So now you see this is a pretty long expression, and a little bit of heavy calculations are involved. So let's be patient and try to work it out step by step. So therefore immediately we can take the constants out, right? So that means we can write minus h cross square multiplied by alpha divided by pi to the power 1 by 2, and then minus infinity to plus infinity e to the power minus alpha x square by 2, and then we can write that ddx of ddx of e to the power minus alpha x square by 2 dx. All right, so that we can write. And then what we can do here, that let's first do these things part by part. Right, ddx of e to the power minus alpha x square by 2 is equal to, we can write that it comes out to be minus then 2 comes out, by 2 cancels out, alpha x e to the power minus alpha x square by 2. All right, so then again we have to take the derivative of this value. All right, so ddx of, then ddx of e to the power minus alpha x square by 2. Okay, this becomes is equal to, once again, ddx of minus alpha x e to the power minus alpha x square by 2. All right, so that becomes is equal to, so minus comes out, becomes positive, alpha square, 2 cancels out, x square e to the power minus alpha x square by 2, and then once again minus, we have to take the derivative of this, alpha e to the power minus alpha x square by 2. Okay, so this becomes our expression, and then we can take e to the power minus alpha x square by 2 part common, and then we get alpha square x square minus alpha. All right, so finally this is our expression, so we are going to put it here. So is equal to, we can write, okay, so here we already have a negative sign outside, so we can take the negative sign inside. So we can write h cross square alpha by pi to the power of half, then we have minus infinity to plus infinity. So remember we have this part minus e to the power minus alpha x square by 2, and here, so it would become e to the power minus alpha x square. So if we take the negative sign inside, it would become alpha minus alpha square x square whole multiplied by e to the power minus alpha x square dx. Okay, so correct me if I am wrong. So this becomes the entire expression now. All right, so I am erasing the bottom part. Okay, so here then we have to make it simplified once again. So h cross square alpha by pi to the power of half. Okay, so we can break these two integrals, minus infinity to plus infinity. One we have alpha e to the power minus alpha square dx. Okay, and again minus, once again, h cross square alpha by pi to the power of half minus infinity to plus infinity, alpha square, we can take the alpha square out, of course, so we can take that alpha square out, okay. Then x squared e to the power minus alpha x squared dx. Okay, so as you can see, this is a pretty long expression. All right, so once again, then we can take the help of the standard integral of this part and the standard integral of this part. Okay, so okay, here the alpha part is there also, so we can take that alpha part out over here. Very good. All right, so now how to take the standard integral of this? It is again also given in the standard integration table, and this part we have already done it. So similarly, we have to apply those expression from the standard integral, and we have to do little bits of tedious algebra or mathematics, and then ultimately that we are going to find out that this whole long expression is equal to h cross square multiplied by alpha by 2. Okay, so it's your job once again to verify whether this is equal to this for px square n is equal to 0. All right, so while you verify the expression, then I'm going to erase this, and let's try to find out the expression for px square average for n is equal to 1. So let's do it. Okay, so similarly, uh, so here we have already find out the average of px square at n is equal to 0 is this, and similarly for n is equal to 1, the average of px square gives rise to this long expression by taking psi 1x. Okay, so this part we have written, and we have taken the constant parts out, and then multiplied by this px square operator operating on this function, okay, with only the variables. So once again we can take this minus h cross square out, and then we have to take the double derivative of this function and again multiply it with by this function, and again we apply the formulas of standard integral to find out the final expression. So doing all those mathematics, so you can verify it. Okay, this would give rise to an expression h cross square 3 alpha by 2. Okay, this is for n is equal to 1. So by observing this one and this one in the same manner exactly as we have done for average of x square, so we can write that the average of px square for n is equal to any is equal to h cross square alpha multiplied by n plus half. All right, isn't it so? So that means for n is equal to 0, so we can write where n is equal to 0, 1, 2, etc. For n is equal to 0, we have h cross square alpha by 2. For n is equal to 1, we have h cross square multiplied by 3 alpha by 2. Okay, so then we have found out this px square average, so therefore we can write that sigma px square okay is equal to we have h cross square alpha n plus half. All right, so this is our value, and so we are on our way to find out or to verify Heisenberg's uncertainty principle, and we have already seen what is the value of sigma x square square. All right, okay, so let's find out the value of sorry sigma x. Okay, sorry, so here This is the expression for uncertainty. The square of the uncertainty of momentum, sigma square px, and here would be the square of uncertainty of position, so sigma x square. All right, so let's write down the expression and let's find it out. Okay, here we go. So we have found out that sigma x square is 1 by alpha n plus half, and this is sigma px square. So now we are going to take the product of these two. That means sigma square x multiplied by sigma px square. So the product gives us that this is once again we can write this multiplied by h cross square alpha n plus half. All right, so we are going to delete this part. So this is equal to alpha alpha cancels out, and we have h cross square n plus half whole square. All right, so this is equal to sigma x multiplied by sigma px whole square. So now we have seen that the uncertainty, according to Heisenberg's uncertainty principle, the product of sigma x and the sigma px, that means the product of uncertainty of position and the uncertainty of momentum, is equal to, here we are taking the positive roots, h cross n plus half. All right, so n plus half. Okay, so now what we can see that, so this is equal to h cross divided by 2 for n is equal to 0. All right, and this entire value is greater than h cross divided by 2 when n is greater than 0. That means n is equal to any other non-zero values, 1 2 3 4 etc. So therefore we can see that the product of sigma x and sigma px is greater than is equal to h cross by 2. So hence Heisenberg's uncertainty principle has been validated in an harmonic oscillator. All right, so this is a pretty these are pretty long derivations, but I want you to try it out by your own hand and practice it so that you can get all the expressions correct. All right, so now here we are going to observe one more thing, that is, what is the value of the average potential energy and the average kinetic energy. All right, so average PE is equal to, the expression is P square x average divided by 2 mu. Here mass is replaced by a mu, and then the average kinetic, sorry, this should be the average kinetic energy, and then the average potential energy. All right, average potential energy is 1 by 2 k, and then x square average. Okay, so that we can find out for any value of n. Okay, so where n is equal to any, and here also we can prove n is equal to any. All right, so we have already got the expression for px square average. All right, and we have already got the expression for x square average. So you find out those two expressions that we have already derived, and you plug in the value, that value here, and again that value here. Okay, if you plug in those two values, what do you get to see? Okay, so that is my question. So verify, if you just plug in those two values, you will see that the average kinetic energy for quantum harmonic oscillator is equal to average potential energy, and it's your job to show that whatever this value is equal to En divided by 2, and here En divided by 2. Now the question is, what is En? So En is nothing but, we have done h nu n plus half, okay, divided by 2. Here also h nu n plus half divided by 2. Okay, so here we have to you have to derive it. So how can we find out nu from here? So remember, all these terms, these two terms contains the expression alpha. Okay, so originally you find out what is the definition of alpha. So that had been given in the previous lecture, the expression for alpha, and alpha contains the part k, all right, and mu. So from the k part and mu part, okay, how you can relate to the new part, so that's your task basically. So you please find it out this way. And the most important outcome is the average kinetic energy is equal to the average potential energy. So that means what? So that means that the total energy for any state n, okay, is equally divided between the kinetic energy and the potential energy. So that was the major outcome of these calculations that we have done today. So there is one more important part remaining for this quantum mechanical harmonic oscillator part, and we will going to discuss that as the last lecture of this chapter, that means chapter 4, in the next video lecture, which is lecture number 23. So till then, you please try to study this calculation and make sure that it makes sense to you, and keep studying and stay safe. So I will see you in the next lecture. Till then, goodbye.